In this video, we're going to take a look at simplifying square roots that have variables in them. Our steps are similar to our last video. We want to factor the numeric part of the radicand, just as we did before. We also want to factor the variables. So we might just write out our list of variables and then continue with steps 2 and 3 from before, where we remove pairs and put them outside the radical and then simplify. So let's take a look at our first example. We have the square root of x squared. If I'm going to factor x squared, that's just x times x. Do I have a pair of x's there? I do. A pair gets represented once outside the radical. The square root of x squared is just x. Let's take a look at 9k10 under the radical. Maybe you remember the square root of 9 is 3. That's our double number. So that is a pair, and we'll represent that once outside the radical. Now the k's, there are 10 of them. So I'm going to list all 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we're going to go ahead and circle our pairs. We have 1, 2, 3, 4, and 5 different pairs. So outside the radical, I'd write each of those pairs 5 times. I have 3, and then I have 5 k's. Outside of the radical, you're going to simplify these k's. You'll have the 3, and since there are 5 k's, that's really k to the 5th power. Noticing we're taking 10, and since we're looking for pairs, we're splitting this in 2. So if I divide 10 by 2, I'm going to get the 1, 2, 3, 4, 5 pairs, and that's the 5 to the exponent that I have on the outside. We'll try writing them out, but we'll also try dividing and see what we have. So our next one, we have the square root of n to the 5th. So I have 1, 2, 3, 4, and 5 n's. If I look for my pairs, there's 1, there's 2. Okay, I only have 2 n's. They're going to go on the outside of my radical, and my single n will go inside the radical. Right? These go here. This one goes there. If I were to rewrite that outside the radical, I have 2 n's. That's n to the 2nd power, and a square root of n on the inside. Let's factor 40 like we did before. 2 and 20, 2 and 10, 2 and 5. I see that I have 1 pair of 2's, so I know that's going to be outside the radical. And inside the radical, I'm going to have my 2 and my 5. But I also have all these a's, and we have 19 of them. That's a lot of a's to write. I wonder if there's a simpler way. Well, yeah, we're looking for pairs. So I'm wondering how many times does 19, can I take 19 and divide it by 2? 2 goes into 19 9 times. 9 times 2 is 18, and there's 1 left over. So we're going to get 9 pairs. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, and 9 pairs. So that means we really have 2 and then 9 a's. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have our radical. We had 2 times 5, which is 10. And then this single a is also out there. Now, of course, we can simplify all of these a's. We said there were 9 of them. So that's really 2a to the 9th radical 10a. This is our simplified answer. So let's see if we can do the next one without having to write all these letters out and just dividing that exponent by 2. The square root of 25, that's one of our perfect squares. It factors into 5 times 5. So this is our pair. So I know there's a 5 on the outside of the radical. Then I look at x to the 6th power. If I take 6 and divide it by 2, I get 3. That means there's going to be 3 x's on the outside, or x to the 3rd power. Then I have y to the 13. Well, if I divide 13 by 2, I'm going to get 6. That means I'm going to get 6 y's on the outside. But there is 1 left over, so that's going to stay in my radical. Again, you could factor out and write out all of your x's and look for the pairs. That's why we have 3 out here. And write out all the y's. And circle our pairs 1, 2, 3, 4, 5, and 6. That's why we have y to the 6th. And this single y is going to stay in the radical. You try the next one. P to the 7th, Q to the 4th, square root P, Q, R. $63 is not a perfect square. Let's see, I know 3 goes into it. 3 goes into it 21 times. And 3 and 7. So here's our pair of 3's. They're going to be outside the radical. And then we have our b's. We have 2 of them. They're also outside the radical. Do we have anything left over? Yeah, this single 7 is going to stay in the radical. This is going to be 3 to the 9th. Or 3 times 9, I should say. And 3 times 3. Here's a pair of 3's. They're outside the radical. This 3 is going to go in the radical. And then I have 3 n's. 2 of them are going to be outside the radical, and 1 of them will be in the radical. On number 9, we take the 8 and we put it outside the radical. We just bring it along for the rest of this. So now we need to factor 320. We can do 2 and 160, 2 and 80, 2 and 40, 2 and 20, 2 with 10, and then 2 and 5. So there's a lot of 2's. So we've got 1, 2, and 3 pairs of 2's. 1, 2, and 3 pairs of 2's. The 5 is going to go in the radical. I have an x, it's just a single x, so that's going to stay in the radical. And then we have 4 y's. So we've got 2 pairs of y's. That's going to be yy. As we simplify, 2 times 2 times 2 is also 8. 8 times 8 is 64. We have 2 y's, so that's y squared. And we're left with 5x under the radical. Bring the negative 2 along. Put that out in front. And we're going to multiply whatever else we can pull out of our radical. 2 and 90. 2 and 45. 5 and 9. Ooh. And 3 and 3. I have a pair of 2's, so that's outside the radical one. I have a pair of 3's, that's outside the radical. My single 5 is going to be in the radical. we have a pair of u's. They're going to be outside the radical. And my v is going to stay in the radical. As we simplify, we have negative 2 times 2, that's negative 4, times 3 is negative 12, u radical 5v. You might want to pause the video and try the next few examples on your own. You need to erase this work right there so we can work on the next example. Circling my prime numbers. I see that I have 1, 2, 3 sets of prime number pairs, so they're going to come outside the radical. My single 2 is going to be in the radical. I have 5 p's. So I have 2 sets of those, and 1 in the radical. And then I have 18 r's. If I divide 18 by 2, I'm going to get 9. So I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9 r's outside the radical. My r's aren't showing up here. So if I simplify everything outside the radical, 2 times 2 times 2 is 8. 2 p's are going to be p squared. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9 p's, 9 r's, I should say. So that's r to the 9th. Square root 2p. And our last one, we're going to bring negative 5 out in front. When we simplify the square root of 144, I'm going to get 2 and 72. I know that's 9 and 8. Well, that's interesting. I didn't pick prime numbers. If you do that, that's okay, but you have to then keep working your branches. And that's important to know. If you don't pick prime numbers, there's still things that you can do. So I have a pair of 3's here, I have a pair of 2's here, and I also have another pair of 2's. Oh, I don't have any single numbers left under my branches. So can we take the square root of 144? We can. That's a perfect square. We get 12. If you don't recognize your perfect square, that's okay too. You can still factor it, but you'll have pairs for all of your numbers. X to the 16th, when we divide 16 by 2, we get 8. So I know I'm going to have 8 x's out here and nothing left over. When I work on the y's, 10 divided by 2 is 5. So I'm going to have 5 pairs of y's out there. And for z, I have 7 z's. So 7 divided by 2 is going to be 3. But I'm going to have 1 z left over under the radical. So now we got to put all this together. So negative 5 times 12 is going to give us negative 60 for the numbers. Then we have x to the 8th, y to the 5th, z to the 3rd, and square root z. I'm going to kind of cross my z's here so they look like z's and not 2's. And there you have simplifying radicals with variables.